Each element in the periodic table gets its own little square, and on a typical periodic table, that square contains a number representing the atomic number, a letter or a couple of letters that are the elemental symbol, and generally they also have a mass. That is the mass of that element. In the example on your screen, you see the box corresponding to the element carbon, and it says that the mass of carbon is 12.0107 grams per mole. This is not the true mass of carbon. It's a weighted average. Remember that atoms can have different isotopes. So carbon has 3 naturally occurring isotopes: carbon-12, carbon-13, and carbon-14. If you just take the mass numbers for these isotopes, add them all together and divide by 3, you would get an average mass number for the element. In this case, 12 plus 13 plus 14 divided by 3 equals 13. And this number is absolutely not what you get for the mass on the periodic table. There are 2 problems with this. One, the mass numbers do not correspond to an actual mass. It corresponds to numbers of protons and neutrons, not their weights. The other problem, and this one is a little bit more significant, is that not all isotopes are equally likely to be found in nature. We need to consider the percent abundance of each isotope as it's actually found in nature. If you went and found any given random sample of carbon atoms, these are the isotopic abundances. Out of your random sample, over 98% of them will be carbon-12, about 1% will be carbon-13, and less than 1 times 10 to the minus 6% of them will be carbon-14. That means the average mass of carbon in a random sample is going to be a lot closer to carbon-12's mass than it is to carbon-14. And there's an expression for calculating a weighted average like this. The way you find a weighted average is to take the mass of the isotope, multiply it by its isotopic abundance, and then do that for all the different isotopes and add the resulting values together. So we'll do the calculation for the different carbon isotopes, and we won't use the mass numbers, we'll use the actual masses of each isotope. And you find that the weighted average mass is approximately 12.01, which is very, very close to the value on the periodic table.